Now we will study steps of on our message synchronous IPC mechanism. Okay, first we will study from server side. Server side, what are the steps we need to follow, and the client side, what the steps we need to follow. So first in QNX, everything is IPC mechanism is communicated by a channel only. So first we need to create a channel that we can create by a channel create function, IPC function. Okay, so first we will study the on theoretical explanation, then will follow the program. Okay, then if I create a channel, so next I need to attach to a name. Okay, this name attached to a name it should be present in slash dev, then name, then locals, then that whatever given name it should be there. Okay, so it will be local name and global name. We can create a global name and a local name. So global name you need to pass other flags to name attach. Okay, by default it will create inside local. Okay, then yeah, that's I mentioned name flag attach global, that will attach the name globally instead of local. Okay, then now I created a name, so it is look like a name and pipe only. Okay, so now I created a name. Next what? Next I need to send a message or message receive. Server side what? Server side mostly we need to receive the message, right? So we need to receive message receive, so that should be present inside a while loop, infinite while loop. Okay, then next is message reply. This is for we just got the message and we need to reply. If it is error, then message error we need to do. That is from server side. Then what from client side? So server is created a name attached, right? So we need to link with the server and the client. Some ID. So for an example, now server program, client program. Then we what should be the present? What should be the same? Port ID should be same for server side and client side, right? So in here we need to follow the same name. So there we actually that name is we creating for channel ID. We should follow same channel ID, because channel ID is on the passing from server side to client side, client to server is very difficult. Because of that we are using name attach. By a name attach only we can create the channel ID. Okay, so name attach and the name open. This name open will return the channel ID. Okay, CID. So that is we will get connect to the server using it is name. Okay, so that is name open, and send the message to the server. So send message. What message you need to send? You want to send that you can send via message send. Message send parameters. What are the parameters? COID. That message. Next is message. That message is anything, structure or array. Okay, that is just a pointer, that is a buffer. Okay, next variable, what is this next variable? Next variable size of that message. Okay, so that is in here, and next is I think that one resource structure is there. We will study all things about message send. Okay, then message send, then here also we need to do message receive. Okay, wait for message receive. Here they are sending message reply, that right? So we need to receive that one. For that we need to use message receive. Then we are closing that pipe. That is a simple our IPC mechanism, synchronous message IPC mechanism. Okay, now let's move to the next. How we will create a channel. So what are the header file we need to follow? Header file we need to use hash includes is neutrino.h. Okay, what is the different functions we can use for channel creation? Channel create and channel ampersand r. Okay, so channel create pulse pool on the pulse pool also is there. So the return value of channel create is a channel ID. Okay, that identify the newly created channel owned by the calling process. Most manage Just use a single channel for most. So this channel ID we need to pass to name client. Okay, name attach. Okay, once created channel is owned by process and it is bound to the creating thread. If a process want to other process to communicate it, it is typically uses name attach. That's what we said, name attach or resource manager attach. Here we are explaining with the name attach. Okay, to create a channel and associate and name it with it. Okay, so that actually what is happening in the channel will create it with the ID and it will attach it to a name. That name we can directly call from client side. Okay, so that sender side process uses name open name open respectively. That name, okay, locate the name and create and a connection to it. That is I explain. Okay, next function what will. So these are the flags. Okay, these all we need to check with the call QNX document. Okay, these all are disconnected. If anything disconnected, our client is disconnected, then it will send the message pulse signal for that only. Okay, a process acting as a server would implement an event loop to receive and process message. Okay, so loop we need to create. That's what I said. Okay, a server can also use name attached to create a channel and I associate a name with it. And the sender process can then use name open to locate that name and create a connection to it. So I'll show the program for okay. So this is our client side. So first client is what is happening, name open. Okay, this is server name. I given one name, server name. Okay, this same name I given in server program also. Okay, so what is this is a message T. I just sending message. Okay, so what is clients? First, I will explain server side. So server side, CHD channel is created for communication, and we got the CHID channel ID. This channel ID we need to attach into the name. So name, this name attach will return one structure is there, name attached T. Okay, so we are checking that it is null or not. Okay, and then we need to pass chid here. Okay, that is mistake here. Then it is attached to that name. Okay, then next is what we in a while loop. This is what mentioned, this while loop, and inside while loop what they are doing, they are waiting for message who will send, client will send. Okay, then message, this is just a message, the same message size should be. Okay, this is a structure only, same structure only, client also sending. Okay, then sending, we are checking that the return value of message receive. Message receive will return the receive ID. Okay, if receive ID is -1, then message receive is failed. If it is equal to 0, then we are receiving pulse instead of our message. So we need to check why we need to receive pulse, because it is client is exited or not, disconnected. If that information we will get from pulse only. Okay, and then we need to check the message type. This is message type. We can create different type. Okay, for that one more variable we should create inside that structure. Then we are printing that message and just replying to the message. Okay, that is the server side. Client side, what is happening? Client side, COID we are getting name open with the server name. Server name, what is server name? Same server, right? My server. Here in server side also, my server, right? See that both names are same only, right? Then client what need to name open. So now we are getting name opened successfully. So we now we can send the message. So I am creating one a simple message here, hello server. Then message send we can use. What message send? COID. This COID will get from name open. Okay. Then we are sending message, and then we are wait for the response. Wait for the response from the server side. Okay. This is server side. The server is sending message reply, right? For that we need to use message receive here. Okay. So this is the then we are closing name close. So that is the server client program. So channel. Then what is next? LIFO. Okay, that is your name attach and name open as a part of. So what is happening here? These functions allow you to use a name instead of channel ID. Okay. Instead of channel ID, it will open communicate with the make it easier to manage communication without needing explicitly share or manage channel IDs. Because if you are using another connect attach functions, then it will be difficult. The server will now use name attach to create a named creation point that the client can connect. Okay. Then name attach function what? Name attach function prototype is name attach. Then it is return type is as one structure name attach attach t and name attach function. This is dispatch dpdd. Then path. This path we need to give what name you are creating. Okay, just give the name and the unsigned flags. These are the different flags. You can that is functions behavior. Okay, globally or locally. That is the meaning. These are the header files you need to use. What IO function dot and system dispatch. Okay. This is the that structure, name attached structure. So what are the instead? CHID, then MNTID 0. Okay. CHID is the channel ID and DPP is the dispatch ID. This is the dispatch. Okay. Dispatch handle. Okay. Then MNTID is the mount. That mount ID for this name. One name will create that name. Then name close function. Name close function, same name close in the COID. Okay, that is the function. Next, message receive and the message receive are. Message receive, we have the function arguments chid channel id, then one message. This is our message. Okay, that is my size of message. Then this is the message info structure. Okay, this is the parameters. And we message info, that is a null. Usually we use null if we don't want to extract the informations from message info structure. Okay, this inde means the return it will return the message receive id. Okay. Today we are going to study about IPC mechanism in QNX. Okay, so first we are going to study about synchronous message passing. Why it is called in synchronous message passing? most of the time synchronous means what? And the clock is required, right? So you here not, it is not because of clock. Okay, synchronous means we are need a feedback. Okay, yeah, here client. Okay, these are the different services and implemented in message passing in kernel, signals in kernel, and a POSIX message queues, that is external process, shared memory process manager, pipes external process, and FIFO external process. Okay, so last time we are, yeah, synchronous message passing. So now we will study why it is called in synchronous message passing and why. Okay, so we have two process or two threads. Okay, that two threads is communicating each other. That's why we need IPC mechanism, right? So one thread will send the data and another thread will receive the data. So who is sending the data, that we can call the client. Okay, and who is receiving the data, that we can assume it is a server. Okay, so server always, what will do, server always waiting for the messages. It will be like an infinite loop only. It can control multiple clients at a time. So here we are synchronous message passing, we are using multiple APIs are available. May we first focusing only message send and message reply. So message send, name itself you can identify, it is sending message. So who will send message? A client. So first client will send a message. Okay, a thread that does a message send to another thread. Okay, will be blocked until the target thread does a message receive. So what will happen? Client send a thread, then client send a signal or some data to the server. So server, what server should do? Server should call the message receive. Otherwise, it will go to the it will be blocked. So what will be the blocked? Send blocked. That you can see here. Okay. So message, the client is does a message send. Okay. Then send blocked. So when server does a message receive, then only it will move to reply blocked. Okay. So in Neutrino, a server thread typically loops or waiting to receive a message from client thread. That's what I'm said. It is like a infinite loop. Whether a server or a client is in ready state, if it can use the CPU. So who is in ready state, it can use the CPU. So we need ready state to get the CPU. Okay. So it might not actually be getting any CPU time because of its and other threads priority and scheduling policy, but the threads is not blocked. Okay, what is means to say, if thread went to ready state, one thread is got the ready state, but many other high threads are there with high priority than current thread. So what will happen? That that current thread will not get the CPU time because the priority task will take care. So the so first we will check the client. Okay, client thread. This is the client thread. Okay, client thread. It is showing what it is going send blocked, then the reply blocked, then only it will move into the ready state. So what is happening here? Client is sending message send, then until it will receiving message receive from the server, it will send blocked state. Once it is received, then send it move into send block to reply blocked state. If any issue error is there, then it will uh, then it will any error or any after that message reply is happening. Okay, message receive, then message reply. So message reply should be executed by the server. Here you can say the process may and execute as message reply. Okay, so that's what I am written here. First is changes of state. If the client thread calls message send and the server thread has not yet called message receive, then the client thread becomes send block. Once the server thread calls message receive, the kernel changes the client thread state to reply blocked, which means that server thread has received the message and now must reply. Okay, when the server thread calls message reply, the client thread becomes ready. So now you got the answer why it is calling synchronous message passing. So this is they depend upon the server and the client always depend upon the server. Server is dependent client. If the client thread calls message send, client thread call message send, and the server thread is already blocked on message receive. Okay, it is already in message receive, then the client thread immediately become reply block, skipping the send blocked state completely. If the server thread fails, exit or disappears, the client thread becomes ready with message send indicating error. So this is the client side is happening. Okay. Now we will move to the server. Server thread. What is server thread? So server thread changes of state for a server thread in send receive reply transaction. Okay, send. If a server thread calls message receive, okay, server thread. So when client send a message send, then message receive we need to call, right? So that message receive here they're explaining, and no other thread has sent to it. Okay, then the server thread becomes receive blocked. Server thread becomes receive blocked when another thread sends to it. The server thread becomes ready. Then only a server thread becomes ready. If the server thread calls message receive and another thread has already sent it to it, then the message receive returns immediately with a message. In this case, the server thread doesn't block. Okay. If the server thread calls message reply, it doesn't become blocked. So these are the different. This is the message send and message receive. Next we are going to I will explain the with the program. Okay. So first we'll complete this theoretical explanation. Right. So if you like my video, then like and subscribe.